Ford fans, Mike D here, Engine Product Manager at Ford Racing. We're here at PASS, Performance Assembly Solutions in Livonia, Michigan. We're here to take a behind-the-scenes look at the Coyote Aluminator engine build. You know, the guys here at PASS have a solid track record of building serious Coyote horsepower. These are the same guys that built the 5-liter engines for the 2013 Cobra Jet drag cars. Some of these cars have already run in the high 8s at 150 miles an hour. With me is Mike Robinson, Engineering Manager at PASS. Mike leads the assembly process that transformed these Coyote Mustang GTs and Boss 5-liter engines into the Ford Racing Aluminator NA, Aluminator SC, and the new Cobra Jet inspired Aluminator XS crate engines. Mike, get us started on the crate build. I understand there's basically 4 areas in the build.
That's correct. The process is broken down into 4 main areas: teardown and prep, gauging, assembly, and end-of-line test.
Now, I know that you guys have really put in a lot of high-tech quality controls. Tell us a little bit about that story.
Sure. The assembly process features an operator touchscreen interface at each station, which integrates a set of live on-screen work instructions together with an electronic fastening system, an in-process torque-to-turn verification system, a leak tester, and an end-of-line cold test operation, which verifies rolling torque, oil pressure, and compression.
Okay, good. Now, just like a regular production engine, these things are serialized as well, and there's an identity of the engine. Tell us a little bit about that.
That's correct, Mike. Each engine is serialized with a barcode and a part type identifier. That barcode is scanned in at each operation, and it's used to define the specific assembly sequence or build recipe that is required to be completed at each station. Every step of that process is monitored, and it's recorded in a database, and an engine birth history report can be generated at any time as required.
That's great. Tell you what, let's head inside and take a look at the line.
Very good. We start with a factory fresh engine. We disassemble it down to the bare block, which is then inspected, deburred, cleaned in a high pressure jet wash, then followed with a rinse with fresh water. We then dry it with compressed air and wipe the bores down with light oil to prevent rust and corrosion. The gauging operation is completed on the block, crank, rods, and pistons. All critical dimensions are measured and clearances calculated and recorded against the engine serial number on an assembly traveler. All key features on the rotating group are also measured to ensure they meet specification prior to subassembly. The factory piston and powdered metal rod is replaced by a Manley H-beam forging, also featuring ARP 2000 rod bolts and a Molle forged piston, dished for the 9.5:1 application or flat top for the 11:1 application. Main bearings are individually sized to specification. They are then installed into the main caps and the block. The rebalanced crankshaft is then installed into place, followed by the main bearing caps, ensuring they are placed in the correct positions and orientation. The main bearing cap bolts are then installed and tightened in sequence per specification using an electronic torque gun. The torque and angle results for each fastener are recorded into the traceability system. A fixture is mounted to the block. The crank is then rotated. Peak breakaway torque as well as average rolling torque are then measured and recorded in the traceability system. The piston and rod assemblies are lubricated with oil, then installed into the block. The connecting rod caps and bolts are then installed. Finally, the rod bolts are then torqued to specification using the electronic torque gun. After the piston and rod assemblies are installed, the torque-to-turn fixture is once again mounted to the front of the block. The crank is again rotated, and we measure peak breakaway torque and average rolling torque once again. The oil pan baffle and gasket and oil pump pickup tube are then installed, followed by the multi-layer steel head gaskets, and finally the cylinder heads. The intake and exhaust camshafts are then lubricated and installed, followed by the cam caps, ensuring correct placement and orientation. At the second assembly station, the camshafts and VCT phasers are reinstalled, and the engine is timed by aligning the ID marks on the gears with those on the chains. The engine assembly is completed by installing the cam covers, front cover, and intake manifold before proceeding to the end-of-line test operation. End-of-line test begins with a coolant cavity leak check. Each engine is tested to verify no leaks are present, and the leak test results are recorded in the database. The engine is then rolled into a cold test stand, primed with oil, and spun over to verify oil pressure, torque to turn, and compression of each cylinder. Before the engine is spun, it is primed for 2 minutes with heated oil. It is then tested at 2 different RPMs to verify oil pressure and rolling torque.
Ford Racing has taken the Mustang GT 5-liter Coyote engine and created another in its series of Aluminator crate engines built to deliver even more performance in either naturally aspirated or supercharged form. The 5-liter Aluminator NA, SC, and XS engines are built with extreme duty manly connecting rods and mallet pistons designed specifically for high performance applications. The 5-liter Aluminator engines are a direct bolt-in for 2011 to 2014 Mustang GT and are also becoming one of the more popular engine swaps for street rods, vintage muscle cars, or resto mods using Ford Racing's 5-liter engine controls pack. Go to FordRacingParts.com to find a Ford Racing dealer and learn more about the full lineup of Ford Racing parts.